you again. Thank you very much for having me here. It's a pleasure to come back to Istanbul. And today I'm going to show you a mix of everything that we have been telling you during the day and during the day of tomorrow too, and the practical workshop. I'm going to show you not just the autologous cell therapy, but also animal therapy to human beings, xenotransplantation. So it's a mix-up. We are going to mix some tools in a practical work in cell therapy. Let's start with the method. So we have three groups here. The first group is the one that I'm going to focus, which is the precursor stem cell therapy, which is the transplantation of cells from the animals to human beings. So we use the xenogenic transplantation because these animals can be studied. We can see the animals, we can study the animals, we can certify the animals. We have a lot of work done with the animals, several articles published on animals. So I'm going to explain afterwards how can we do that, but we use prime source of fetus animals to apply to human beings. The other ones is the autologous that you know already, okay? So fat cells, blood cells, bone marrow cells, everything that have been listened to, it's under the autologous stem cell therapy. And the other one, because my pointer is not functioning, is the immunotherapy, autologous immunotherapy. I am an immunologist, and my main work is to put the support of immunity to my patients. Every kind of pathologies is linked to the immunity, so I'm always doing immunotherapy in order to enhance the immunity, modulate the immunity, and make them feel better, whatever the technique I'm using afterwards. So, three groups. Here you can see at this table here that you have the tissues. So you can see there brain, frontal cortex, ovary, testes. There you see the animal's cells. There you see how can you work with. You just have to choose. It's like a menu. A restaurant menu. You see the animal sources and you can focus on your patients, directed the treatment. The difference between the autologous and the animals is that you can find out the differentiated tissue to apply to your patients and still being a stem cell, because we take from the fetus. So they are developed, but they are still stem cells. So here you see the person that developed everything from the beginning of the last century, the Paul Nichens. The concept is the similarity. You have the receptors alike, human beings and animals, and he started to work with the diabetic patients because they didn't have insulin, so he started to push pancreas from the pig to the human beings and so on, and then he started the development of xenogenic cell therapy, xeno from the other species to another one. So here you can find in those cells all the peptides, exosomes, biological factors, growth factors, immune factors, everything that you can find in a stem cell, but a little differentiated you find in the animal cells. But here you have different kind of treatments with the cell therapy from the animals. I'm just going to explain to you how it functions in human beings, okay, without any rejection, without any problem. We have two different kind of recognition. First, the direct one. The animal cell has the same molecules, the same sequence of amino acids that is recognized by the histocompatibility complex. You know that, for example, here we use sheep cells. They are cleaner, better to certify and so on, or rabbits. So if you see here, we have the sheep cells, and the sheep antigens are recognized by the histocompatibility from the sheep. But our histocompatibility major complex, HLA, will co-recognize the same molecules here. So once the animal's cells enters by the sheep histocompatibility complex, our cells, T cells, by the receptors of the T cells, will recognize those cells and will understand that they are not strange. They have the same molecules, they have the similar proteins. So they will process, and they will process to our histocompatibility complex. So from one animal to the human being, the recognition will tolerate. The T regulatory cells will understand that, and then the animal cells will function. Of course, now we have the technology to treat those cells before, so they don't have antigens. They just have the same sequences that the human being can understand. So the other one is the recognition by phagocytosis. The cells are phagocytized, and then they are expressed to our complex. And in order to be recognized, the molecules have the same complexes sequences. The T cells from the human being will recognize our own peptides presented by our own cells, but from the animals. So we have those two kind of ways to work with cell therapy from animal to human beings. So here you see that and then they take from, for example, the sheep, 1 or 2 fetus, and the other one will live. Okay, so they won't be depressive and so on. And with that, you can donate all the cells from the menu that you can choose and personalize to your patients. Here, for example, we have the first step. Now you understand the animal cells, but I want you to understand the steps. First, we are going to begin with the peptides, not the cell therapy, not the full precursor stem cells, but the most specific peptide coming from the mitochondria of the organs. So this is very nanotechnology, this is very purish the free radicals. First of that, it can control the oxidative stress. Secondly, those peptides will activate a series of cascades that can protect the body. And I'm going to say to you how, but normally they protect the cell from inflammation, first of everything. Secondly, it changes the metabolism in order to decrease the sugar and more effective, faster, and burn more fat. So it turns the yellow to brown fat very easily and protect the heart. You see here, the mitochondrial peptides are nanopeptides, very small. They have bioactive agents from the cells to start the self-renewing of the cells. Here you have, for example, what those peptides can do. They can protect from stress, as you see here. They can regulate the inflammation. They do neuroprotection, cardioprotection, because there is no side effect at all with those kind of peptides coming from the mitochondria. Afterwards, I will show to you how I work, but just for you to understand, we take the cells from the animals. Of course, the lab will purify. There are several steps to make the cells just specific to be applied. The good things with the peptides, as they are very small molecules, is that you can inject through all kinds of specificities. For example, subcutaneous. Now we have the primary cells from the animals. They are frozen under 200 degrees. And they go through an enzymatic process that takes off everything that we don't need and just leave the cells and the factors that the human being can recognize. So the frozen cells are like that, okay? Work intramuscular, more personalized, of course, more powerful. And then you have here the comparison of the cells. For example, when you take from the precursor fetal, you can find